Hello, and welcome to the wonderful world of logic models, or what we like to call Logic Models 101. So before I begin, first I'd like to just introduce myself. My name's Keely, and I'll be taking you through this training. And I'd also like to introduce you to a couple of my colleagues who may be popping in to help us out from time to time. This is Tuan, Tony, and Amber. So, today we're going to go over a couple of things. We want you to come out of this training having a basic knowledge of logic models, why they're used, what they're used for, how to read them, and also how to build them. But where to begin? So there are literally thousands of resources out there that will teach you how to make and use logic models. But in the end, all logic models are really just a map. They tell us where we are, where we want to be, and they provide a logical way to get from where we are to where we want to be, or a way to solve our problem. So all logic models have their roots in three things. The first is problem definition. You need to know exactly what your problem is before you can solve it. So in this case, we're in Siberia, and it's really cold, and we don't want to be there anymore. The second element is goal setting, or what we're going to call in this training the long-term outcome. So you need to know exactly where you want to be in order to get there. In this case, California, because it seems way warmer than Siberia. The third element is reverse engineering. So you need to know how to get from the problem state to the ideal state, or your goal, and to do it in the most effective and efficient way. So instead of taking this route through Greenland, it's probably better to take this much more direct route so that we can get to California as quickly and efficiently as possible. So some problems are really easy to define. My car just stopped on the highway. What on earth happened? Oh, I ran out of gas. Makes sense. And equally easy to reverse engineer. I need gas so I can drive. I need someone to bring me that gas because I can't drive to get it. AAA will totally bring me that gas. I'll call AAA, they bring me gas, and off I go. Easy. Let's give this one a try. I'm starving. So the problem definition? Why am I starving? Oh, I haven't eaten all day. And the reverse engineering? I don't want to be hungry. I need to eat something. There's a Twinkie right there. I'll eat that Twinkie. I'm full. Problem solved. Off I go. But when problems become a little bit more complicated, we can use a tool called a problem tree to help us figure out the causes and effects of the problem. So the problem is going to be the trunk of the tree. The causes are going to be the roots of the tree. And the effects will be the branches. So let's test it out. I've gained a lot of weight. Why is that? So let's build a problem tree to figure it out. The problem is I'm overweight. The cause is I have unhealthy eating habits. And I really don't exercise. I have unhealthy eating habits because I don't know how to cook healthy food. And I also don't really know of healthy snacking options. I don't exercise because honestly, I think it's really boring. Let's also look at the effects. Physical activity is getting harder as I gain more weight. There are also lots of long-term negative health effects. But how do I solve the problem? I need to lose weight. Now we all know that solving this problem is a little bit harder than defining it, especially if that Twinkie solution is a common one for you. But we can build a logic model to help us figure it out. So our long-term outcome is going to be, I want to lose 10 pounds in 6 months. Sounds reasonable. But how do we do that? You can build a logic model by looking at the problem tree you created and correcting the causes. So let's look back at our problem tree. I'm overweight because I have unhealthy eating habits and I don't exercise. So let's start there. If I want to lose 10 pounds in 6 months, I need to decrease the amount of junk food I eat, because that's one of my main problems. And I need to increase the amount of exercise I do. Now let's look back at kind of what feeds into those major causes. I have unhealthy eating habits because I don't know how to cook healthy food. And I also don't know of healthy snacking options. And I don't exercise because I think exercise is really boring. So let's solve those problems. To decrease the amount of junk food I eat, I need to increase my knowledge of how to make healthy food that I like. And to increase the amount of exercise I do, I need to increase my belief that exercise can be fun. So now let's drop in some activities. What's going to get us to those short-term outcomes? Well, I might take a cooking class that teaches me how to make healthy food. I'll receive instruction on how to make healthier meals and snacks, which will increase my knowledge of how to make healthy food I like, decrease the amount of junk food I eat, which will take care of one half of the logic model. And then down below, I need to engage in a fun type of exercise. So I'll join a roller derby team. This will increase my belief that exercise can be fun. It will increase the amount of exercise that I do. And when I decrease the amount of junk food I eat and increase the amount of exercise I do, I can lose my 10 pounds in 6 months. So that's simple enough, right? Reverse engineering like that is something that we do every day with all of our problems. We make solutions, we do it for ourselves personally, and it's not really all that hard. In order for you to lose weight, you probably don't really need to make a logic model. But what happens when I'm overweight becomes there's an obesity epidemic in this community? Those problems are more difficult to define. So let's stick with the same theme, but do it on a community level. The problem is the obesity epidemic. The causes are that our community has unhealthy eating habits because they don't know how to cook healthy food. They don't know of healthy snacking options. And eating healthy can be really expensive. Also, people are doing little to no exercise in this community because they believe that exercise is really hard and boring. They really don't have time. It's really hard to self-motivate. And joining a gym is really expensive here, and people just don't have the money. The last cause is going to be healthy living is really hard in this community. The grocery store doesn't really have much produce. It's not easy to walk places. Parks are dangerous and kind of dirty. And it's dangerous to ride a bike in traffic here. So, at the root, our causes are the community does little to no exercise, healthy living is really hard here, and there are unhealthy eating habits. What about the effects? So we're going to have the same individual level effects that I had. Physical activity is becoming harder, and there are also long-term negative health effects: diabetes, heart disease, and high cholesterol. Then there are also societal effects. So there's increased absences from work, increased healthcare costs, and also unhealthy habits are passed to children, really creating that cycle of obesity. When you put it all together, we're going to have all of our causes and all of our effects together so we can reference back to build our logic model. So from problem tree to program design, again, you're going to use that problem tree to build your logic model. So if our problem is the obesity epidemic in town, our causes again are little to no exercise, healthy living is hard in this community, and we have unhealthy eating habits. And then we have all the other causes that cause those three main ones. Now, looking at this helps us to define our problem. But without a methodical approach to solving the problem, your thought process may look a lot like this. What should we do? Oh, how about bike lanes? Maybe a farmer's market? We could do a bike share. What about community gardens? How about cleaner parks? Cooking classes? Exercise classes? Community education about health? Okay. Now, who out there really wants to implement that program? Sounds like a nightmare, right? But by building a logic model, we can actually create logical links working backwards from our long-term outcome so that we can know what our activities are producing and why they're producing the results that we want. So we have our long-term outcome, community members lose weight. Our intermediate outcome, community members eat healthier food, and community members exercise more. We have the short-term outcomes that lead to those intermediate outcomes. So community members gain knowledge of healthy recipes. They gain knowledge of healthy food choices. They are able to find healthy and inexpensive food. Down below, where we need community members to exercise more, community members can take advantage of public spaces. Community members encounter new free ways to exercise, and community members learn fun ways to exercise. We drop in our activities, which consist of community education workshops on nutrition, organizing farmers markets, opening community gardens, making parks more attractive, designating bike lanes, and coordinating free community exercise events. We'll put in our outputs, which we'll explain a little bit more, but are just really the receipt of those activities. So you can see that all of our activities are going to flow into our outputs, into our short-term outcomes, into our intermediate outcomes, and finally into our long-term outcome. All of our causes in our problem tree are reflected in this logic model, so that we can see that it's the root causes that we're treating, and that we have a logical way to trace the activities to the outcomes that we want to achieve. Logic models are becoming the norm in many fields, including international development, health, education, and social services. And they're used systematically by many organizations, including the World Bank, USAID, many of the United Way partners, including the Latin American Youth Center, and the Department of Health and Human Services, among many, many more. So if you want to get ahead in this world, it's time to know how to use logic models and build them to make programs and organizations more effective.